All right, this is grading exercise video 5-2, part 2. We've graded the road and the shoulders and the ditch. Now we're going to do the culvert and provide for drainage under the street. So first thing we can do, in the last video we figured out these contours were 6.7 feet away, so to go half a foot. So if to go 6.7, every is 6 inches, we've got to go a foot for, this is contour 54, 53, we got to show contour 52, which if 6 inches here to here is 16.7, we're going to go a full foot. So this contour from here to here is 33.3 feet, and so this is 54, 53, 52 is going to be another 33 feet away, right? Same distance as here to here. So let's just measure that on both sides. Let's see, contour. So if we go 33.3, puts us right here. Same thing on this one, 33.3, roughly here. So what we've got is, this is 52 and 52. This is contour 52.2. So this is above contour 52. So because this is the top of the road, or the road, we got to figure out what the pipe contour, the pipe elevation is, the invert elevation in and the invert elevation out, as well as the top of the road, or the top of the shoulder at these locations. So how are we going to do that? We got 52 obviously is going to go down in the pipe and tie into 52. Let's see, this 53, 52 doesn't cross the road, so here's 52. 52 is going to go this way in the pipe, out here, connect to these, and somewhere along here. So let's figure out our contours at the edge of the pipe. So we said that this is 6-foot shoulder and a 12-foot road, so we're looking at to the top of the road here. We're going to go 52.1. Let's see, so this is 52.5. We're going 2% and then another 2%. And that is, if we measure from the center, then we got 12 and 6, that's 18. 6, 52.5, 4. So top of the road, this is 52.5. Let's just go a total of, hang on here, 52.1. If we go from here to the end of this pipe, that's 19 feet. 19 feet. We don't know what the drop is, so we don't know the vertical. We know the horizontal, we just measured, it's 19 feet, and we're going to divide that by the slope. It's going down at 2%, right? 2%, 2%, 0.02. So, oops, sorry, that should be horizontal times slope, because we're trying to find vertical, not divided by. So 19, we're doing vertical, times 0.03. 19 times 0.03 equals 0.57. Is that right? We'll check, move my solar calculator to the light. 19 times 0.0. Oops. That shouldn't be 3%. That should be 2%. Because we are, so we're going 19 feet at 2%. We're following these slopes right here, 2%. So 19 times 0.02 equals 0.38. 0.38 feet. So we drop 0.38 to the top of the pipe right there. If we go 52.5, or not the top of the pipe, top of the road, 52.5, 52.5 minus 0.38, 38, 52, 52.12. So this right here, we're just going to do this. 52.12. So this is still above 52. So that's contoured. 52 doesn't come up here at all. And then the bottom of the pipe, if this is 52.5, how much cover do we have? Let's see. Bottom of pipe is 2 feet lower than the spot elevation for the road. So the bottom of the pipe is 2 feet lower. This is 52.5. So bottom, I'll just write bottom of road, or bottom of pipe, equals 50.5. So if that's 50.5, what's the invert elevation here and the invert elevation here, which is invert in, invert out? It's 50.5 in the middle, and we said the pipe was 19 feet to the end there. So we want to find out what the vertical is. We know the horizontal is 19 feet. We just measured it. 19 feet, and we're going to multiply that by the slope, which the slope they give you up here, the pipe culvert slope is 0.5, so 0.5%, or is, oh yeah, is 0.5%, so 0.005. See that? So it's 0.5%, which they give you it's 0.005. So 19 times 0.005. 19 times 0.005 equals, that equals 0.095. So if we subtract 50.5 and we subtract this 0.095 from that, what do we get? 50.5 minus 0.095, 50.4. So 50.4. Oops, you know what? 50.4 is the bottom, because the pipe is sloping this way. So 50.5, I have to take that number, which we just calculated, the 19 feet. To go this direction, we have to add it, right? Because we're going uphill. Going this direction, we're going downhill, so we got to subtract it. So down here, this at the bottom is 50.4, and on this side we got to add, so 50.5 plus the 0.095 equals 50.6. It's 50.595, 50.595, but we're going to make it 50. We're just going to round up to 56. 50.6. So this is 50.6. So all we did was we calculated this is 19 feet at 0.5%. So we did that calculation, 19 at 0.5%, 19 times 0.005 equals 0.095. So from this elevation of 50.95, we had to subtract it going this direction because it's going downhill, and we get 50.4. This direction we had to add it because we're going uphill. This half of the pipe is going uphill from this point, so it's 50.6. So if the pipe invert elevation in is 50.6, invert elevation out is 50.4. Now we know, let's call this, we've got to determine what this slope is right here. So this is contour 54, so let's make 54 right here. We'll just make this 54 because it's at the end of our line, the end of our center line, so we can, it's whatever you want to be. I mean, you can make it any slope you want, but what we're going to do is we're going to make it 54 because we got to tie contour 54 back in, and we don't want to go off the page. So that's why I selected 54. Let's go. Now we know this is 54 and this is 50.6. Let's figure out what our slope is. Distance, it looks like it's 52 feet. So we're going 52 feet horizontally. We're trying to find slope. Slope equals vertical divided by horizontal. So we're going slope equals vertical divided by horizontal. So what's our vertical? 54 minus 50.6. So 54 minus 50.6 equals 3.4. And we slope equals vertical divided by horizontal. Horizontal is 52. What do we get? 3.4 divided by 52 equals, so 0.65. 0.65. So 6.5%. 6.5%. Is that right? We're going 52 feet. Right scale, 52 feet. 52 feet. 50.6. 3.4 divided by 52 is, oops, not 0.65, 0.065, 0.065. So that's 6.5%. So let's try it out. So that's 6.5%. Let's see. 50.5, 52. Just checking myself here because scale that says. Well, that's 52. So this is 52 feet. 52 feet. And we're dropping 3.4. 54, 3. So if that's 6, let's do our contours here. Now we know our slope. Let's try this. 6.5%. So 0.065. This is 50.6, the inward elevation. So now we got to go find our whole contour. So we got to go uphill 0.4 feet to get to 51. So we know 0.4 feet vertically, right? To get to contour 51, we're just trying to find the contours on the center line of this drainage. And we're trying to figure out horizontally what that distance is. So horizontally, vertical divided by slope, which is 0.065 equals 0.4 divided by 0.065 equals 6.15 feet. 6.15. So let's measure 6.15 feet. All right, 6.15 is going to put us 6 right in here. And then if we're going, now from here we got to go a foot, because that's 51. Now we got to 52, 53. Oh, wait a sec. 50.6 is the bottom. Let's see here, 50.6, so 51, yeah, this is 51, 52, 53, 53 is going to tie in here, and then this is 54, 54 is going to tie in, so that should be 1 foot. We're going to go from 50.6, 1 foot, at that same 6.5%. So we're going to go 1 foot divided by 0.065, and that equals 1 divided by 0.065 equals 15.4 feet. 15.4. So does it go 15? So 15.4 puts us there, and then 15.4, that would be 51, 52, 53. 53. Oh, I see what they did. This contour is so much steeper, or this slope. I'm at 6.5%, and I was trying to figure out. In the book, they had 4.8%, but they made this contour 53 right here instead of 54. So I picked 54, so that was going to make that steeper, which we could still do, but they just tied in contour 54 into this, so they only tied in contour 53 over here, then they went off the page. So that's what the difference is. I was just a little confused there on why this was off, but now we've got it. So now we've got 52 feet. So instead of the 3.4 feet, I'm going to use 53 here. Again, this is confusing, might be a little confusing because this is a number you just have to pick, and I picked 54, but that changes the book, from what they've got in the book. So I'm going to use 53. And then 54, this contour is going to tie into 54, goes off the page, we won't worry about it. So 53, then it's, instead of 3.4 feet, it's 2.4 feet, right? So if we go 2.4 feet divided by 52, 2.4 feet vertically divided by 52, because I just measured 52 feet, that equals 2.4 divided by 52 equals 4.6, 0.046, so that's 4.6%, which is closer to what they have in the book. I didn't want to confuse you guys, but I probably did. But we're going to use 4.6%, that'll be 53, so 50, now that we're using 4.6%, we'll use the same over here. We'll just use the same exact slope of 4.6%. And let's figure out now, since we've got to go 0.4 feet, right, to get to 51 vertically, 0.4 feet, 0.4. And now instead of dividing by 6.5%, we're going to divide it by the 4.6%. So 0.046. And that equals 0.4 divided by 0.046 equals 8.69. We're just going to call it 8.7. So now we'll measure 8.7, puts us right about here. So I'm going to put this contour here is 51. So I'm going to put 51, and now we've got to go a foot from 51. We've got to get to 52. 1 divided by 0.046. 0.046 equals 21.7. So what I did was, now we've got 51. We've got to go a foot vertically at 4.6%. So we just did 1 foot divided by 0.046 equals 21.7. 21.7, almost 28 feet. So now we just measure 20, 5, 6, 7, 8. As we measured here, 21.7, 21.7 puts us right about here. And so this is 21.7 to that contour. The next one should be 21.7. So this is 53, 52. I'm going to draw this in red so you can see it. So now what we've got is, here's contour 51, 52, 53 on this side. And what we've got to figure out, this is where it gets a little confusing when we're in class talking about it. Now, the bottom of our pipe right here is 50.6. So we've got to go to get to 51. Where does 51 fall on this wing wall? Well, we're going to go 0.4 feet, right, vertically. 50.6, we got to add 0.4 feet vertically to get to 51. So let's write that down. We got to go 0.4 feet, right? And it says here that our maximum slope is 5 to 1. 5 to 1 is the same as 20%. 1 divided by 5 equals 20%, or 0.2, right? Is the same. 25 to 1 is 20%. So if this is 52, or if this is 50.6, we got to go 0.4 feet along this wall, and we're going at 20% horizontally. Here is our horizontal equals vertical divided by slope. Vertical 0.4 divided by our slope, which is 0.2, right? 20%. That gives you 0.4 divided by, 0.4 divided by 0.2 equals 2 feet. 2 feet. So 0.4, 20%. We go 2 feet. So along this wall, we just measure 2 feet, which puts us 1, 2, right about here, and then another 2 feet from that invert spot elevation puts us right about there. So our contour, that's 51. That's where it falls on that wing wall, and then it goes like this. I'm drawing in red so you can hopefully see these contours like that, and then it goes down and through the pipe. And this, the bottom, this pipe is 50.4, so we got to figure out where 51 is on here. So there's 53, there's contour 51. Where does 51 fall? If this is 50.4, 51 is going to be 0.6 feet away, right? We got to add 0.6 to this. So let's do, I'm going to write 0.6 vertically to get to 51. 50.4 plus 0.6. We got to divide that by our slope, which we said was 20% for the wing wall, right? Maximum slope 5 to 1, 20%. What does that give us? 0.6. 0.6 divided by 0.2, 3 feet. So now we're just going to measure over 3 feet. At this scale, it's pretty small, but it's basically right in here and here. That's where 51 comes down, comes out right here, and then it's got to tie back in to 51. So now we've got 51 on these wing walls. It's got to tie into 51, so we're going to come out here and just tie in here, come out here, tie in here. Don't worry too much about this. I know it might seem a little confusing, but it will get, the more you do this, the easier it gets. So here's 50 now. We've done that contour. It goes in through the pipe, comes out, ties in. Let's go ahead, tie these contours in. So this is 53. 53 has to tie into contour 53. It's back here, so we're just going to go tie in like that. 54 has to tie into 54 here, like that. Over here, 53 has to tie into 53. So we can just go 53, 53, 53. Now 52, we have to tie 52 in. And 52 is going to have to go on this wing wall. See how we have contour 52? We haven't tied in. We've got 51, and so we've got 52 has to go in between because this is 53 and this is 54. So where does 50, if that's 50, what did we say the top up here was? If this is 52.12 at the top of the road, same thing, we're going to go, where does 52 fall on this wing wall? Well, we've got to drop. We're dropping 0.12 feet, right? 0.12. That's because to get to 52, and we're, again, on this wing wall, our maximum slope on this edge here is 20%. So divided by 0.2 equals 0.12 divided by 0.2 0.12, is that right? 0.12, 0.12 to 0.12 puts us at 0.12 divided by 0.2 equals 0.6, 0.6. So, lost my camera there for a sec. So 0.6, so it's almost to the edge, a foot. So you would measure about from here. Actually, if we went 1 foot up, let's do 1 foot is 51's right here. So 1 foot up. This is very confusing, but just bear with me. 1 foot. Let's go 1 foot divided by 0.2 equals 1 divided by 0.2 equals 5 feet. Might be easier to measure this way around at 5 feet. So from this contour, we got to go around the wing wall 5 feet, which means puts us right in. Basically, you're wrapping around the wall this way, 52, and then you're wrapping around this way, 52. It puts you right about here. I just measured 5 feet around, and that's where 52 hits. So we need to do this at a bigger scale, but anyway, this is the best we can do for now. So 52, we got to tie into 52, 52, 52, and 52. So we've got to bring this around, something like this, and then we have to get to 52 over here. And we got to come from here, 52 through here, around, and I made a basically drains this way, and this way. That is, I know that's very confusing, but it's the best we can do for now. So 53, we've got to tie into 53, which is going to come same thing. And remember, you have to stay at least 5 feet away, so you can 5 to 1 get that close. Something like this. Same thing on this side. You can come 5 feet away, because it's 5 to 1 for this contour. We're just tying these contours back in. So this is 53, this is 52. Alright, so that's what that looks like. And then 54, we got to tie 54 back in, which comes in right here. 54 has to tie in here. And then on this side, 52 is going around, and then it's coming around the wing wall and going through the pipe. And we've got to do the same thing over here. If this is 51 at 5 to 1, we've got to go 5 feet, which is going to basically put us, if you just measured 5 feet around this wall, you'd get right around to almost the opposite side. If you just scaled it, it's 5 feet, because from 51, we got to go 1 foot at 5 to 1. Puts us right at 5 feet, so that's about the distance if you measure. That's about 5 feet horizontally. Now from 52, we got to tie back into 52, and it has to go from here to there. 50 contour 52, and then contour 52 over here, like that. So hopefully that didn't fry your brain, but that is how this problem works for exercise 5-2. Good luck.